In this video, I'm going to explain the functionality of the component Application Lifecycle Deployment Engine, or ALDE, belonging to the TANGO project. So, in this example, I'm going to focus on one concrete example. Imagine that the application was made with the TANGO programming model, and that source code is passed to the ALDE, where ALDE is going to create a Singularity container. This Singularity container is then uploaded to a testbed platform that has a device supervisor, a TANGO device supervisor compatible with Singularity containers. Then the user of ALDE is going to configure that application to be used in these types of configurations. One configuration just specializes in using CPUs, other ones in using GPUs, and other ones in using CPUs plus CPUs. So we can see the functionality of ALDE preparing for the same code, same application, different versions that are optimized for different types of heterogeneous hardware. And those configurations are going to be executed on the device supervisor, that in this case is the device supervisor being developed in TANGO. For brevity reasons, we are going to probably cut some parts of the video, but in this case we are going to show one application, Matmul, being built by ALDE. So the first thing that we do is to define the application side ALDE, and ALDE is a REST API. So we are going to create the application Matmul demo, and you will see that here you see the curl post indicating the REST API that you use to build the application. Now we have defined an application, a name for that application in ALDE, and now we are going to upload an executable source code to be compiled to be in a Singularity container. So we are now specifying first the ID of the application and also where it is the source code of Matmul plus the name of the source code. So now the code is uploaded. In the background, ALDE probably is starting to compile the application. Now we are going to show this. And as you can see, the status is compiling and the type of application is Singularity programming model. We can see also the log, and we are basically monitoring here this command. So we're seeing when the application is being finished to compile. So we are not probably going to wait for all the process, so we are going to cut a bit the video here. And once we have the application compiled, we need to define exactly where we are going to execute that application. So we defined a deployment, and we defined it in a specific testbed that we already have defined here. That is a compatible device supervisor testbed plus the application ID. So here we have the testbed that is a device supervisor compatible slate version of Slurm. So we deploy the executable to that testbed. So we put the ID of the executable plus the testbed, and the deployment starts. Basically, it loads the Singularity container. Now we see the deployment being already uploaded to the Slurm testbed or the device supervisor TANGO testbed. And now we are going to show also the infrastructure to see it. So we need to pass then a curl command where we are going to create a secure configuration. And the first configuration that we are going to create, that we do it basically via REST API, but we use a script so this process is more faster, is one that is going to use just pure CPU. So we are now launching the script that is going to execute curl, that is going to create the configuration. So we now have a configuration for using 12 cores and no GPUs, and we launch this configuration, and this configuration is being now executed. As we can see here in Slurm, the device supervisor, we see that configuration that is being executed, and we go to the interface of the programming model of TANGO. We can see here also that we have an application being executed that is using 12 cores of CPUs. Now we can do the same with just being the configuration just pure GPU. So we are now launch the script that is going to create a configuration for using just pure GPU application that has been created. And if we go also to the SQ, we will see, first we launch the application, and if we go to the SQ, we will see the application being executed. So the application has been launched, and now also we can see that on the programming model interface and on the SQ, as I was commenting here, right now the application is being executed, just pure GPU, and here we can see that we have assigned 2 GPUs to this application. If we refresh it, select it, okay, we see the graph of the programming model, but more interesting for us is to see that we have 2 CPUs, 2 GPUs being executed right now, and also via the monitoring infrastructure we can see that the GPUs start to be used to start to consume energy that is monitored by the TANGO framework. Now, finally, we can launch, for example, a configuration that is using more GPU power and GPU power. So we call this, it's going to use 12 cores CPU plus 2 GPU. So that configuration is being created. And we see that we are not executing right now anything on the device supervisor of TANGO, but if we launch the application, so we launch execution number 3 that has been created, we see now that's being executed, and we see via the programming model API that we have 3 cores reserved. So we see here, 12 cores plus 2 GPUs reserved for execution of this application.